All right, welcome to Lab 6. So there's not really a whole lot that I need to tell you about. It's going to be about permutations and combinations, like I warned you. And yeah, you're going to take what was in the book and implement it. We're going to do slightly different things, but in general, you're going to take this code for both of these, for gen permutations, gen subsets, and more or less implement it as it was. Okay? So there are some slight differences, and I'll get into that. The first difference is we are going to not be printing out. We're not going to be printing out our permutations that we generate. We're going to be just saving them. We're going to make a vector of them. All right, so it's going to be like the first permutation is like the numbers 1 through 3 is like 1, 2, 3. So it's like you're going to push it back. So it's like perms dot pushback. And then you're going to do that again. Like every time you generate another permutation as well, you're going to add it to your list of all the permutations that you know about so far. So we're going to generate a giant list of all the possibilities. That's easier for me to grade you on instead of printing. Okay, so that's more or less what that will need to change into. So like you'll add, like if this is your perms vector, like you'll add the permutation 1, 2, 3, then 1, 3, 2 in lexicographic order, of course, and so this will get large. And then next perm, instead of taking separately all those numbers, there is a way to have variable length function parameters, but we're just going to pass along a whole vector. We're just going to pass along a vector of what our current permutation is, and you'll just return a new vector, right? A new vector of that permutation. That's all. That's kind of the main difference there. There's also going to be templates involved. We're going to permute more than just numbers, for example. And then for subsets, it's going to be very similar. It's like instead of this, outputting things, it's always going to be pushback. We're going to also generate all the options. Push back. Rather than just printing out all the options. Okay? Can I move that? Yeah. This is another pushback. Alright, so you're just going to generate another vector of all the options. And similarly, like this whole thing, you're passing n, of course, and you're also passing an entire vector. Alright, so it's like 2 parameters. This is a whole vector. Right? You're going to have to worry about these indices, though, because they're starting at 1 in the book, and it's 0 in vector land. So you're going to have to keep that in mind, because like this calculation has to do with the k that's here, starting at 1, not 0. So just remember that. And then, yeah, what you're going to do is return a whole vector representing that particular order for this subset. Okay? Because you can't actually return a set data structure or a set type thing, because that like removes the ordering. We care about the lexicographic ordering. We need something before and then something after. So we're going to represent the sets as vectors. Okay. So yeah, that's more or less it. Let's look at the write-up. It's really not a whole lot that I need to tell you. So here's all the files. It's going to be implemented in a header file because we're going to use templates, because we're going to generate permutations and combinations of not just numbers, because that's not good enough. All right, so here's like the differences to the book's code. For every sequence, we're going to use a vector, and then instead of permuting 1 through n, we're going to permute any vector that contains elements that are sortable, because that's all you have to worry about, right? So for example, there's no reason why we can't permute hello world and blah using this code, because it's just like go and find things that are less than, greater than. We have those implemented for strings too. Okay. And then we're not printing anything out, so we're using templates because of that. Like it should work for any type that has less than, greater than. And also we're not printing out any permutations or subsets. We're going to be building up a vector of all the ones that we generate in that order. Okay, so the tests are caring about the order. Most of these functions are templated, so we're going to be working in the header file because you can't have an attached CPP file. And we're going to be lazy for a couple, though. They're going to not be templated, but we're going to put them in the header file anyway, which is bad practice, but it's easier to just put all your implementation in one place. So that's it. Okay. Dun, dun, dun. And then finally, like there are standard library functions that kind of do this. Obviously, you can't use them for this lab. That's not fair. So just make sure to not look at those. And so yeah, use the makefile and then run my tests. So yeah, the one thing you're going to work on is this generation.h file. So let me show that to you. Whee. So here's what you're going to be working on. So here's legitimately from the book. You got next perm, generate permutations, all right? And so what you're getting is, it's always a vector, right? It's a vector of your current permutation. You're giving it back a new vector of the next permutation, okay? So like, instead of taking separate arguments, it's taking a vector of n things, like next perm on this should return this, yeah? And it's templated. It should work for anything with a less than implemented for it, okay? And then here's generate permutations, again, arbitrary vector of something, vector of t's. You want to create a vector of vectors, all right? So you're going to start an empty vector and start adding to it all the different permutations that you generate. So really, these should be curly braces in here too, but you get the idea, okay? So yeah, just remember that. My hint for you for checking, for like when you're done, the first permutation is the sorted items, right? And the last permutation is the reverse sorted items. You can use sort, that's allowed, okay? So there's that. Yeah, I think that's what I wanted to say. So like, yeah, instead of printing, we're going to get a vector of vectors, a vector of all the possible orderings, all the possible permutations, and we'll just return that big thing, okay? You can also assume that items does not contain duplicates, all right? That's important, because then like you'd have arbitrary orderings. I don't want to get into that, or maybe not, honestly, but let's not worry about using less than versus less than or equal to. It's okay. And then, so that might involve duplicates, and we don't want to need to remove those. So that's next perm and generate permutations. Just like implement the book's algorithms. There's that one. And then, let's see, I've given you this already. This is going to generate the combinations of a vector of arbitrary things, like a vector of strings maybe, given the size as well. Like we need what size of subsets to generate. So this is the templated function, and it's going to use the functions that you write. So I'm going to make genlex subsets of just the normal numbers, like you're going to implement actually this for numbers. Like for subsets, you are just going to implement the number version. And I've wrapped around your version to like take those numbers and use them as indices to generate lexical combinations, lexicographic ordered combinations of your elements of the original vector. All right, so like I'm going through this using your stuff because you're making vectors of ints now, and I'll use those as indices into this subset, into the original set of items. So it's perfect. Okay, so that is templated, but these ones are not templated. All right, so next subset and genlex subsets, this is exactly the stuff from the book on integers even. Okay, so here's n and s for next subset. And so the whole thing is just one big vector. Call it S, big S. And it's your job to return the next one, so it's another vector. We're representing subsets as vectors as well, okay? Because we need ordering. You can also just assume that the test will never call next subset on the last subset. Like it's your fault if you do it here too, because you're supposed to like watch out for it, right? Make sure it's not that one before you try again. And so you can implement your code with that in mind if you'd like. And then genlex subsets is as you would expect. It's going to take R and N, generate a vector of vectors again. So you're gonna build all the possibilities rather than outputting them. So just like for this one, you're gonna build all the possibilities. Start an empty vector, keep on adding each subset you create. Okay, push back, push back. And then you get to use my fancy function to make combinations of arbitrary items. So yeah, you're welcome. So I think that's all you're gonna be working on. It's not a horrible lab. I made a testing file for you. Just run it. You don't have to make any of your own tests or anything, but here it is, including the library. And then here's all my tests. Just making sure like, here is the ordering if you're permuting these numbers 1 through 5. This is the correct ordering in lexicographic style. For those, here it is with Pokemon names, because why not? And then for subsets, here it is like checking that the numbers are working, and then it's also using my stuff to make subsets of Pokemon names. So yeah, apparently the last subset of Pokemon that I'm using is that one. Okay, so like I'm just making sure that your stuff is the same as my stuff. And yeah, so compile, run, get it working. I think that is everything I wanted to tell you. So I went over the write-up, we did it. You're turning in that one file, and that is lab 6. So yell at me if you have any questions, and good luck.